you remember we all remember the spectrums for our typical blue LEDs or white LEDs. They have a nice spike here, a big drop here at 490, and then come back up here. Also successfully missing this important wavelength. All right, so we can see, so there's an issue of lux not changing in the long-term care home. There's an issue of the, especially here, and the spectrum not changing with time. Okay, so because lighting is designed for vision, okay, and not for trying to do our clock. Okay, now, can changing lighting help? Okay, let's look at some papers. Okay, and last August in 2019, these guys in Denmark published that varying the CCT reduces night awakenings. Okay, yes, okay, so 2019, one paper. Another paper, varying CST improves PSQI. Okay, that's a Pittsburgh Standard Sleep Quality Index. It's a survey. So if you trust surveys, this is this person's work, saying that using this survey they found very clear effect of dynamically lighting and affecting the CCT values during the daytime versus nighttime. And Professor Chen has done something about light stimulation during night can help improve sleep. So a lot of stuff came out last year about dynamic lighting having some positive effects. Although there is one study in 2020 which they said there's no effect. Okay, so there's still, so you cannot say it's 100% agreement on this. We have one study coming out in 2020, yeah. Okay, so what conditions do, in their work though, one of the crucial issues are the conditions they use in all these works. They're all in LTC environment, the tests are done, and they use light boxes. Okay, the patient's basically directing light into the patient's eyes. Not exactly and captive patients, because if you're trying to get people to sit in front of a box, you have to have the nursing staff, etc., to be pushing them to comply. Compliance is often an issue. Okay, so our goal now is to try to solve these problems with lighting. So I tried to introduce the problem. I hope you think it's a worthy problem to try to solve, but that's what we're working for. Our goal then is to deliver lighting effectively. Okay, first, vision first. We can't sacrifice vision to achieve sleep goals. Okay, people still have to be able to see, right? So we want to try to, so in our lighting system, we hope to exceed both the Alzheimer's Society guidelines for patients with dementia and also CIE guidelines for senior lighting. They are not the same. Okay? We want to ensure that the white light, according to Alzheimer's Society, must have a CIR rating of more than 90. We want the lighting to be shadow-free and glare-free. Shadows are a key cause for falls for seniors. They see a shadow, especially if they have dementia, and they try to step around it because they think it's an object. When they make the move to step around, you see my mother sometimes almost like she's dancing and then she catches herself. She would catch herself. I mean, that was because of a shadow. So we want it to be glare-free, we want it to be uniform. We also need to be viably financially. It must be cost-effective. And I think the other issue we want is to be able to upgrade as better LEDs arrive, right? Once we have LEDs that can emit at 490, we want to be able to easily swap in LEDs at 490 to be able to optimize the system. And we want it to be user-friendly or very familiar. So I want to give you a little talking about that. We first of all had our nice first version my students gave me. It was beautiful. Beautiful control panel using Node-RED IoT node red system, beautiful pictures, graphs, etc. We looked at our friends look at it and say, nobody's going to want that. It's too complicated. What do we need? So next version. No good. So here comes this is our final version. One switch. On, off. Familiar. They are used to it in their house. Audio feedback. We know the switch has been turned on or off. It's a three-way switch, so we can place them wherever we want. One by the bed, one by their desk, one by the entrance to the room. It uses ESP32, low power. So it's battery powered, so we can just stick it onto the wall. And wherever they are, these switches can be hit, and it will change. If the lights are off, they will go on. If they're on, they will go off. The buttons are large, and it's what the elders are familiar with. They don't have to learn anything new. And since it's using low power ESP, the batteries last about 2 to 3 years. So after 3 years, the batteries would need to be replaced. So that was another key issue. Our original version of the switch, the batteries died after 2 months, which is no use either, right, for application use. So this is our final solution, along with a smaller switch that is put up high for a nurse. In other words, so that she can override the system and basically one button and turn on all the lights instantaneously for an emergency situation. Okay, so that's the familiar issue, okay? Now, here's my office right now. This is how we basically place these lights in my office. Here's our my students are also enjoying sleeping on our bed in the corner. So the light switch here beside the bed for turning the lights on and off. We are using LED strips on cove lighting. So that's indirect, no glare, and each of the LEDs uses low power, so it allows us to get very uniform illumination. A single transformer sits up here, along with the amplifier and the controller. And so the IoT signals are coming up to turn on and off. We also have, this is the baseboard. In the baseboard, we are placing amber LEDs. Because amber does not affect, you can see, but it does not affect your circadian rhythm because it's outside of the absorption area of the photo PRBG cells, okay? So this light, so if the person then hits this switch during the daytime, the appropriate light for that time of the day will come on. If they hit the switch during the nighttime, it will be, these lights near the floor will come on, so that they will be able to shadow-free walk to the bathroom or wherever they want to go in the house, but they will have no mistake, no mistake that it's day. So, summarizing then, we have LED strip lighting. We are using 6 different types of LEDs in strips. We are using cove-based, so that it's 100% indirect. During the daytime, the upper cove is providing the lighting. In the evening, the lower cove turns on gradually, becoming 100% if it's later at night. We are using ESP32 based. We have 8 channels for controlling the total flux and the spectrum dynamically as a function of time of day. And so it's dynamic 24 lighting algorithm. In particular, we're trying to vary the flux at 490 nanometers while maintaining light for vision. So this would be our current algorithm we're trying to work on. We're still improving the algorithm, but this is basically some of our measurements comparing ourselves to the other systems. So this is basically the maximum light coming out, down. This is a comparison with standard fluorescent lighting that would be used for an old age home versus the lighting that we're trying to do. So basically this is photonic lux, so standard lux that we talk about most of the time for vision. Okay, so basically just comparing the two, by providing this cove lighting, there's only a 16% variation in light level throughout the room. Well, with a standard direct lighting, we have about 30% variation. The horizontal lux, with indirect lighting,